Go outside tonight. Find a clear patch of sky away from the streetlights, away from the glow of the city, somewhere you can actually see what is above you without the noise of human civilization washing it out. Tilt your head back, let your eyes adjust, and look for the brightest steady point of light that is not blinking, not moving, not behaving like a star. You will find it. It will be there. A hard, unwavering point of pale gold light sitting in the darkness like something left on. Not twinkling, not pulsing, just burning steadily in a way that feels different from the stars around it. You have almost certainly seen it before. You have almost certainly looked at it for a moment, registered it as bright, and moved on with your evening without thinking about it further. That light is Jupiter. And the reason you should never look at it the same way again starts with a single fact that I want you to hold in your mind before we go any further. That point of light is the reason you are alive. Not metaphorically, not poetically, not in the vague inspirational sense that people use when they talk about the universe being connected. Literally, physically, causally, the planet you are looking at right now has been shaping the conditions of the solar system for 4.6 billion years in ways that made the existence of life on Earth possible. It has been doing this since before our planet formed, since before the sun reached its current state, since before the asteroid belt finished assembling itself from the debris of the early solar system. You have been sharing this solar system with Jupiter for your entire life, for the entire history of your species, for the entire history of complex life on Earth, and you have almost never thought about what it actually is. Tonight, that changes, because Jupiter is not just a planet. It is the most powerful gravitational force in the solar system outside the sun itself. It is the object that organizes everything beyond it. It is the engine that drives geological activity on worlds that should be frozen solid. It is the shield that has deflected cosmic threats away from Earth, and the cannon that has aimed others directly at us. It is simultaneously the reason life exists on Earth and the most dangerous place in the solar system. And it has been doing all of this, all of it, in complete and total indifference to whether anything is watching. Let's go to Jupiter, and let's understand, for the first time, what we have been sharing this solar system with. Before anything else, before the danger, before the storms, before the radiation and the pressure and the things that live in the space between Jupiter and its moons, you need to feel the scale of this planet in your body. Not in your intellect, not as a number you can recite, in your chest, in the part of your brain that processes physical reality and decides whether something is safe. Because Jupiter is not large in the way that mountains are large, or oceans are large, or continents are large. Jupiter is large in a way that breaks the comparison entirely. Earth has a diameter of 12,742 kilometers. Jupiter has a diameter of 142,984 kilometers. If Jupiter were hollow, an empty sphere in space, you could fit 1,321 Earths inside it with room remaining. Not stacked neatly, not compressed, just in there. Over 1,300 copies of the entire planet you have ever known, fitting inside a single object. Let's make that smaller so it fits inside a human moment. If you drove a car at highway speed, 100 kilometers per hour, no stops, no sleep, just continuous driving across the diameter of Earth, it would take approximately 5.5 days. The same drive across Jupiter's diameter would take 259 days. 8.5 months of continuous driving to cross from one side of this planet to the other. That is the object you are looking at when you see that steady gold light in the night sky. But the size alone is not the thing that rewires your understanding of what Jupiter is. The thing that does that is what the size means for gravity. Jupiter contains 318 times the mass of Earth. Not 318 times the volume, 318 times the mass. The weight of everything that makes up Jupiter. Its gas, its liquid layers, its metallic hydrogen ocean, its rocky core, is 318 times heavier than everything that makes up our planet. And that mass produces gravity that operates at a scale beyond anything in our daily experience. If you could somehow stand on a platform at Jupiter's cloud tops, at the level where the atmospheric pressure matches Earth's sea level, you would weigh approximately 2.5 times what you weigh on Earth right now. Every step would require moving 2.5 times your body weight. Your cardiovascular system, designed by evolution for Earth's gravity, would be working at 2.5 times its normal load just to keep blood flowing to your brain. Astronauts returning from 6 months on the International Space Station, where gravity is essentially zero, need weeks of rehabilitation to walk normally. The effect of 2.5 times Earth's gravity on a human body would be immediate, severe, and without any period of adjustment that would help. But you would never make it to the cloud tops. The reason you would never make it there is something we need to address before we go any further into what Jupiter is, because it changes the entire geometry of the danger. Jupiter has no surface. This sounds like a technical detail. It is not. It is the most fundamental thing about Jupiter that separates it from every other threat we discuss in the context of dangerous places in the solar system. Mars has a surface. The Moon has a surface. Even Venus, with its 460-degree temperatures and crushing atmospheric pressure, has a solid surface you could theoretically land on. Jupiter does not. What appears from space as a surface, those beautiful banded cloud layers in amber and cream and rust that make Jupiter look like a painting, is not a surface. It is the top of an atmosphere that is 70,000 kilometers deep. Below those clouds there is more atmosphere, then denser atmosphere, then liquid, then metallic liquid, then a core, but no boundary, no moment where gas becomes ground, no place to stop. If you fell into Jupiter, you would not hit anything. You would simply fall, and the environment around you would get hotter and more pressurized with every kilometer, until the pressure destroyed whatever was falling long before it reached the center. Jupiter is a planet you can fall into forever without landing. And the Great Red Spot, that oval marking in the southern hemisphere that has been visible on Jupiter since humans first pointed telescopes at it, is a storm. A single, continuous, uninterrupted storm. Its current diameter is approximately 16,000 kilometers. The diameter of Earth is 12,742 kilometers. The Great Red Spot is wider than our entire planet. Wind speeds inside it reach 500 kilometers per hour. It has been spinning continuously since at least the 1600s, since before the United States of America existed, before the Industrial Revolution, before the steam engine, before any political boundary currently on Earth's map was drawn. It has been spinning for longer than any human institution has existed. It was there when Newton was calculating the laws of gravity. It was there when the first European ships crossed the Atlantic. It was there when the Roman Empire fell. It is still there now, and nobody fully understands why. But here's the problem. The Great Red Spot is shrinking. When it was first systematically measured in the 1800s, it was approximately 40,000 kilometers across, larger than 3 Earths arranged side by side. Today, it is 16,000 kilometers. It has lost more than half its size in 150 years. It is still shrinking, and nobody knows with certainty what happens when it finishes. Whether it dissipates quietly, whether it releases its stored energy in some dramatic atmospheric event, whether it spawns new storm systems as it collapses. We are watching the death of a storm that has existed longer than our civilization, and we do not know how it ends. That is Jupiter's surface. That is what you are looking at when you see that pale gold point in the night sky. Now let's go deeper. Imagine you are in a spacecraft, the most advanced ever built. Every system hardened, every instrument calibrated. Every engineer who has ever worked on it has spent their career preparing for this specific environment. You are descending toward Jupiter's atmosphere, and the planet is filling your entire forward viewport. An arc of amber and cream so vast that the curvature is barely visible at the edges, the cloud bands stretching in both directions farther than your eyes can follow. You are not yet inside the atmosphere. You are still in space, and you are already in danger. The danger you are in right now, before a single molecule of Jupiter's atmosphere has touched your spacecraft, is the danger that almost no popular coverage of Jupiter gives its proper weight. It is the danger that destroyed the most sophisticated robotic spacecraft ever sent to Jupiter. It is the danger that would kill an unshielded human in minutes. It is Jupiter's magnetic field. Jupiter's magnetosphere, the region of space dominated by its magnetic influence, is the largest structure in the solar system. If you could see it from Earth, it would appear twice the width of the full moon in the sky despite being 600 million kilometers away. It extends outward from Jupiter in all directions, shaped by the solar wind into a vast bubble that, on the side facing away from the Sun, stretches nearly to Saturn's orbit. Inside this magnetosphere, charged particles from the Sun and from Jupiter's own volcanic moon Io are trapped and accelerated to enormous energies, forming radiation belts around Jupiter that dwarf Earth's Van Allen belts in both size and intensity. At the orbital distance of Europa, the closest of Jupiter's large moons, orbiting at roughly 670,000 kilometers from Jupiter's center, the radiation dose is approximately 540,000 rems per day. Let me translate that number into something your body can process. A radiation dose of 400 rems delivered to the human body is lethal. It will kill you, not immediately. The damage accumulates over days and weeks as your cells fail to replicate correctly, as your immune system collapses, as the biological infrastructure that keeps you alive breaks down faster than it can repair itself. For 100 rems, dead. Europa orbits inside a radiation environment that delivers 1,350 times the lethal dose. Every day, continuously, without interruption. For the entire history of the solar system, the Galileo spacecraft, a machine, a device, a collection of circuits and sensors and aluminum and titanium built by engineers who understood exactly what it would face, was so damaged by Jupiter's radiation environment during its 14-year mission that its instruments failed one by one. Its onboard memory was corrupted by radiation-induced bit flips. Its systems degraded beyond the tolerances they were designed for. It was eventually commanded to crash into Jupiter's atmosphere deliberately, not because the mission was complete, but because its deteriorating systems could no longer be trusted to avoid accidentally contaminating Europa. NASA killed Galileo to protect a moon. A machine built to survive this environment was destroyed by it. Over 14 years of operation inside Jupiter's magnetosphere, the radiation accumulated to the point where the spacecraft was dying. You have been in your spacecraft for 30 seconds and you are already receiving radiation at a rate that your shielding is barely managing. Your instruments are showing particle flux measurements that exceed the design tolerances for every non-Jupiter specific spacecraft ever built. The engineers on Earth who are watching your telemetry are managing their concern professionally. The numbers on their screens are telling a different story. You push forward. Layer 1, the cloud tops. Entry into Jupiter's upper atmosphere happens gradually. There is no sharp boundary where space ends and atmosphere begins. The particle density increases slowly at first, then faster. The first clouds you encounter are made of ammonia ice, the same compound that gives household cleaning products their sharp smell, here forming crystalline structures at temperatures of -110 degrees Celsius that refract the distant sunlight into the banded patterns visible from Earth. The wind hits you immediately, not as a force you feel through the hull so much as a direction on your instruments. A push, then another push, then sustained pressure from a wind stream moving at 400 kilometers per hour in one direction that terminates abruptly at a boundary where the adjacent band is moving at 500 kilometers per hour in the opposite direction. The shear at that boundary is violent enough to generate turbulence that your spacecraft handles but does not enjoy. Every instrument mounted externally is being tested by wind loads that exceed anything in Earth's atmosphere. Jupiter's atmospheric bands are not simply decorative stripes. They are planetary-scale jet streams, rivers of gas thousands of kilometers wide and hundreds of kilometers deep, moving at speeds twice as fast as the fastest winds ever recorded on Earth's surface. The light zones are regions of rising gas. The dark belts are regions of sinking gas. The interaction between them produces the continuous turbulence that makes Jupiter's atmosphere a dynamically violent environment at every scale. The Galileo atmospheric probe, a hardened titanium sphere specifically designed to enter Jupiter's atmosphere and return data, was destroyed 57 minutes after entry. It survived to a depth of approximately 150 kilometers below the cloud tops before pressure and temperature terminated its transmission. The last data it sent showed wind speeds of 720 kilometers per hour. You have been inside Jupiter's atmosphere for 12 minutes. Layer 2, the crushing dark. Below the ammonia cloud layer, the atmosphere changes. The temperature rises. The pressure climbs. At 50 kilometers below the cloud tops, the pressure is already 10 times Earth's sea level, the equivalent of being 100 meters beneath the surface of the ocean. At 200 kilometers depth, the pressure is 25 times Earth's atmospheric pressure. The clouds here are not ammonia ice but ammonium hydrosulfide, a compound that would smell, in any concentration you could survive, like a combination of rotten eggs and ammonia simultaneously. Not that you could survive any concentration of the atmosphere outside your spacecraft. The atmosphere of Jupiter at any depth is composed primarily of hydrogen and helium with traces of methane, water vapor, ammonia, and other compounds. None of it is breathable. None of it is compatible with human biology in any form. At 500 kilometers depth, the pressure is 100 times Earth's atmospheric pressure. The temperature has climbed to levels where the ammonia and ammonium hydrosulfide clouds have been left far above you. The sky, if you could call the dense, dark, hot gas surrounding you a sky, is no longer the swirling amber of the cloud tops. It is darker, denser. The light from the sun, already 27 times dimmer at Jupiter's distance than at Earth's, has been filtered through hundreds of kilometers of increasingly dense atmosphere. You are descending into a pressurized darkness that gets heavier with every kilometer. The deepest point any human has reached in Earth's ocean is the Challenger Deep in the Mariana Trench, approximately 11 kilometers below the surface, at a pressure of about 1,100 atmospheres. Special submarines built specifically for this depth, costing hundreds of millions of dollars, can barely survive it. The pressure at 1,000 kilometers depth inside Jupiter's atmosphere exceeds 1,000 atmospheres, matching the crushing limit of the most extreme deep ocean vehicle ever built. And Jupiter continues for 69,000 kilometers below that point. Layer 3, the ocean that should not exist. At approximately 20,000 kilometers below the cloud tops, far deeper than any instrument has ever reached, far deeper than any material we have ever built could survive. Something happens that has no equivalent anywhere in human experience or engineering. Hydrogen stops being hydrogen as you know it. Under the combined pressure of tens of millions of atmospheres and temperatures of tens of thousands of degrees, hydrogen atoms are compressed so completely that their electrons can no longer remain associated with individual protons. They detach. They become free. And the resulting material, protons packed tightly together with a sea of free electrons flowing through them, behaves not like a gas, not like a liquid, but like a metal. Metallic hydrogen. A state of matter that does not exist naturally anywhere on Earth. A state of matter that can only be created briefly in laboratory conditions using the most extreme pressure equipment ever built, and then only for fractions of a second. A state of matter that fills the interior of Jupiter from approximately 20,000 kilometers depth down to the core. A volume of space that makes the entire Earth look like a marble. This metallic hydrogen ocean is what generates Jupiter's magnetic field. The convective motion within it, the slow churning of conducting liquid metal driven by Jupiter's internal heat, produces electric currents on a planetary scale, and those currents produce the magnetic field that you felt destroying your instruments long before you entered the atmosphere. Jupiter's magnetosphere, that enormous structure that extends to the orbit of Saturn on one side, is generated from the inside of a planet by an ocean of liquid metallic hydrogen that physics says cannot exist but the math says it must. You are falling through it now, or rather, your atoms are. Whatever you were before you reached this depth ceased to be a recognizable object thousands of kilometers ago. The pressure and temperature at this depth exceed every threshold that the molecules making up a human body can withstand by orders of magnitude. The atoms that were you are still there, compressed, dissociated, their electrons stripped from their nuclei by the pressure, but the arrangement that made them a person dissolved long before the metallic hydrogen layer was reached. Jupiter has no surface to bury you. It has simply absorbed you. Your atoms are now part of the planet. They will remain part of Jupiter long after every human civilization that has ever existed is gone. Long after the sun expands and consumes Earth. Long after the solar system has transformed beyond recognition. You fell into Jupiter and Jupiter did not notice. Come back to the surface. Come back to the cloud tops where the amber and cream bands stretch to the horizon and the great red spot sits in the southern hemisphere like a wound in the planet's atmosphere that never heals. Let's talk about this storm properly. The Great Red Spot was first observed in detail in 1665 by the Italian astronomer Giovanni Cassini, the same man whose name was given to the spacecraft that spent 13 years studying Saturn. He recorded an oval feature in Jupiter's southern hemisphere. Whether this is the same storm currently visible or a different storm that occupied the same position is debated, but by the mid-1800s the Great Red Spot was being systematically measured and it was already enormous. 40,000 kilometers wide when it was first carefully measured. 3 Earths placed side by side would not span it. Every cloud system you have ever experienced on Earth, every hurricane, every typhoon, every continental low-pressure system, would fit inside the storm with vast room remaining. The wind speeds at the outer edge of the Great Red Spot reach 500 kilometers per hour. The storm rotates counterclockwise, a high-pressure system in Jupiter's southern hemisphere, completing one full rotation approximately every 6 Earth days. The center of the storm is elevated several kilometers above the surrounding cloud deck. The storm extends downward into the atmosphere for hundreds of kilometers below the visible cloud tops. It is not a surface phenomenon. It is a three-dimensional structure of violent atmospheric dynamics occupying a column of atmosphere hundreds of kilometers tall and wider than a planet. And it has been doing this continuously for at least 350 years of human observation, probably much longer. Think about what that means in human terms. The Great Red Spot was spinning before Isaac Newton published the Principia Mathematica, before Benjamin Franklin flew a kite in a thunderstorm, before the French Revolution, before the American Civil War, before either World War, before the first airplane flew, before the first nuclear weapon was detonated, before the first satellite reached orbit, before the first human stepped on the moon. Through all of that, through every event in the history of modern human civilization, the Great Red Spot has been spinning. On a planet 600 million kilometers away, in an atmosphere with no solid surface to friction break the circulation, powered by Jupiter's internal heat and its own momentum, it has simply continued. But here's the problem. It is dying. The storm that has outlasted every human institution is shrinking at a measurable and accelerating rate. In 1979, when the Voyager spacecraft returned the first high-resolution close-up images of Jupiter, the Great Red Spot measured approximately 23,000 kilometers across. By 2014, it had shrunk to 16,500 kilometers. By 2019, Hubble Space Telescope measurements showed it at approximately 15,800 kilometers. Today, it continues to shrink. In the period of human observation, the 350 years since Cassini first recorded it, the storm has lost more than half its width. If the shrinkage continues at its current rate, the Great Red Spot may effectively disappear within decades to a century. Not in the distant future, within the lifetime of people alive today. Scientists studying the shrinkage have identified several possible mechanisms. Smaller storms in the surrounding atmosphere may be interacting with the Great Red Spot and disrupting its circulation. Internal dynamics of the storm itself, the feedback loops that have maintained it for centuries, may be changing as the storm's size decreases. The relationship between the storm and the atmospheric jet streams that border it may be shifting in ways that no longer support the storm's maintenance. The honest answer is that we are watching something we have never seen before. The death of the most famous storm in the solar system. And our models of Jovian atmospheric dynamics are not yet good enough to say with confidence what happens when the storm finally ends. Does the energy dissipate quietly into the surrounding atmosphere? Does it briefly intensify as it contracts? A last storm of increased violence before it dies, before dispersing? Does its disappearance alter the atmospheric dynamics in its region in ways that produce new and different storm systems? We do not know. We will watch. The Juno spacecraft currently orbiting Jupiter will watch. Future missions will watch. And we will find out what happens when a storm older than our civilization finally stops. And this is where things change. Because Jupiter's danger does not stay on Jupiter. The same gravitational force that drives the Great Red Spot, that organized the atmosphere into those jet streams, that crushed the Galileo probe and irradiated its instruments, that same force reaches across hundreds of millions of kilometers of space and touches everything in the solar system, including Earth. Here is the most important thing you will learn about Jupiter tonight. And I want you to take it seriously because it is not a metaphor or a simplification. It is what the mathematics of gravitational dynamics shows when you model the history of the solar system. Jupiter has been protecting Earth, and Jupiter has been threatening Earth. At the same time, through the same mechanism, for 4.6 billion years. The asteroid belt, the collection of rocky debris orbiting the Sun between Mars and Jupiter, contains millions of objects ranging from dust particles to the dwarf planet Ceres, which is nearly 1,000 kilometers across. The asteroid belt is not, as popular culture sometimes suggests, a dense field of tumbling rocks that spacecraft must carefully navigate. It is mostly empty space, but it contains enough material in enough different orbits that the gravitational interactions within it and with Jupiter create a dynamic, continuously evolving distribution of objects. Jupiter's gravity reaches into the asteroid belt and creates what are called orbital resonances, positions in the belt where an asteroid's orbital period would be an exact fraction of Jupiter's orbital period. Objects that drift into these resonances receive repeated gravitational nudges in the same direction at the same point in every orbit. Over thousands or millions of years, those nudges accumulate. Objects in resonance zones are gradually kicked out of the belt entirely, either inward toward the Sun and the inner planets or outward toward Jupiter and beyond. The Kirkwood gaps, the visible empty bands in the asteroid belt's distribution, are the direct result of this process. Jupiter has been sculpting the asteroid belt since the solar system formed, removing material from resonance zones and sending it elsewhere. Some of that material goes outward, captured by Jupiter's gravity or flung to the outer solar system. Some of that material goes inward, toward the inner planets, toward Earth. Jupiter is not simply a passive shield. It is an active gravitational sorting machine that has been redirecting material throughout the solar system for billions of years. Sometimes that material misses Earth. Sometimes it does not. Every major impact crater on Earth, every extinction-level event in the fossil record that was caused by an impactor, ultimately traces back through a chain of gravitational interactions that includes Jupiter. The asteroid or comet that caused each impact was put on a collision course with Earth by a series of gravitational nudges, some of which came from Jupiter. Jupiter did not aim those objects at Earth deliberately, but Jupiter's gravitational influence was a component in the process that delivered them here. And the evidence for this is not theoretical. July 1994. The confirmation. In July 1994, humanity watched in real time as the solar system demonstrated exactly how violent these processes can be. Comet Shoemaker-Levy 9 had been discovered the previous year, a comet that had been captured by Jupiter's gravity decades or centuries earlier and, during a close pass in 1992, had been torn apart by Jupiter's tidal forces into 21 distinct fragments strung out along its orbital path like pearls on a string. Astronomers calculated its trajectory and made an announcement that the global scientific community received with a mixture of excitement and disbelief. The fragments were going to hit Jupiter, all 21 of them, over 6 days. In July 1994, every major telescope on Earth was pointed at Jupiter for that week. The Hubble Space Telescope had just been repaired months earlier, its corrective optics installed in December 1993, and it returned images of the impacts with a clarity never before achieved. The Galileo spacecraft, currently en route to Jupiter, had a direct view of the impact sites. The first fragment hit on July 16th. The explosion plume rose 3,000 kilometers above Jupiter's cloud tops, 3 times the height of the tallest mountains on Earth above its sea level. The impact scar left in Jupiter's atmosphere was larger than Earth, visible from Earth with amateur telescopes. Fragment G, the largest of the 21 pieces, hit on July 18th. The energy released was estimated at approximately 6 million megatons of TNT. The combined yield of every nuclear weapon ever built by every nation in human history is approximately 6,000 megatons. Fragment G released 1,000 times that energy in a single impact. The impact scar from Fragment G alone was larger than Earth. It remained visible in Jupiter's atmosphere for months. 21 fragments, 6 days. Impact scars the size of planets. The combined energy of thousands of nuclear arsenals released into the atmosphere of another world while humanity watched through every telescope it could aim at the sky. The scientists who watched it described the experience as profoundly sobering. Not because Jupiter was in any danger. Jupiter absorbed every impact completely, its enormous mass swallowing the energy without structural consequence. But because of what the event meant. This happens, not once, in a unique and unrepeatable cosmic accident. This is a process. This is what gravity does with small bodies in a solar system organized around a planet the size of Jupiter. Captures them. It breaks them apart. It delivers them to impacts. And the only reason Shoemaker-Levy 9 hit Jupiter in 1994 rather than Earth in some other year was the arrangement of the planets at the time of the comet's original capture, and the specific gravitational geometry that resulted. A different capture date, a different orbital configuration, a different chain of gravitational interactions over decades or centuries. And the 21 fragments of Shoemaker-Levy 9 could have been on a trajectory toward the inner solar system rather than Jupiter. Fragment G, 6 million megatons of TNT. Earth has no atmosphere thick enough to break up an object of that size before impact. The crater would have been continental in scale. The ejecta would have covered the globe in minutes. The thermal pulse from the impact would have ignited surface fires across continents. The dust and debris thrown into the stratosphere would have blocked sunlight for years. The same event that scientists watched with telescopes and described as one of the most extraordinary astronomical events of the 20th century would, on Earth, have been the end of complex surface life as we know it. Jupiter took that hit instead, not because it was protecting Earth, not because of any process directed at our benefit, simply because of where the planets were when the gravitational story of that particular comet played out. Luck, positional, gravitational, indifferent to whether anything biological was watching. That's not even the worst part. The worst part is what we have found in Earth's geological record when we look at what has happened in the past, and what the patterns tell us about what will happen in the future. Step back from the violence for a moment, because there is another side to Jupiter that is equally true and equally extraordinary, and that almost never gets told in the same breath as the danger. The side of Jupiter that did not just threaten life on Earth, but may have made life on Earth possible, and may have already created the conditions for life somewhere else in the solar system right now. Jupiter has 95 known moons. 95. More than any other planet in the solar system. This is not coincidence. It is the direct result of Jupiter's gravitational dominance. Its enormous gravity has captured objects throughout the history of the solar system, locking them into stable orbits and holding them there across billions of years. 4 of those moons are large enough to be planets in their own right if they orbited the Sun directly rather than Jupiter. They were discovered by Galileo Galilei in 1610, the first objects ever observed to orbit something other than Earth, and they carry his name. The Galilean moons, Io, Europa, Ganymede, Callisto. Each one is a world. Each one is shaped fundamentally by its relationship to Jupiter. And 2 of them tell a story about what Jupiter's violence can produce that changes the entire emotional context of this planet. Io, violence made visible. Io is the most geologically active body in the solar system, more active than Earth, more volcanically productive than anything humanity has ever witnessed on any world we have visited. Its surface is covered with over 400 active volcanoes, lava lakes covering areas larger than some of Earth's largest lakes, volcanic plumes reaching 500 kilometers into space, so high that the material they eject escapes Io's thin gravity and enters orbit around Jupiter, creating a diffuse torus of ionized gas that circles the planet and contributes to the radiation environment that makes the entire Jovian system lethal. The mountains on Io are not volcanic in origin. They are compressional, squeezed upward by the tectonic forces that the constant geological activity generates. Some reach heights of 18 kilometers, higher than Everest by nearly 9 kilometers. Io's surface is continuously resurfaced by its own geological activity. Impact craters, which tell the geological history of every other solid body in the solar system, barely exist on Io. They are filled in and buried by volcanic material almost as fast as they form. Io's surface is geologically new, constantly renewed, constantly destroyed and rebuilt. All of this is powered by Jupiter. The gravitational tidal forces from Jupiter, amplified by orbital resonances with Europa and Ganymede that prevent Io from settling into a circular orbit, continuously flex and squeeze Io's interior. Io's orbit is slightly elliptical. As it moves closer to Jupiter, it is squeezed more strongly. As it moves further, it is squeezed less strongly. This continuous flexing, like repeatedly bending a piece of metal, generates heat through friction in Io's interior. Enough heat to melt rock. Enough heat to drive the most violent geological activity in the solar system. Jupiter is heating a moon to volcanic fury from 420,000 kilometers away. Simply by existing. Simply by having the mass it has and the gravitational relationship with Io that its orbital mechanics produce. Europa, the ocean Jupiter created. Europa is smaller than Earth's moon. Its surface is almost entirely water ice, one of the smoothest surfaces in the solar system, cracked and reddish stained by minerals welling up from below but otherwise a vast, still, frozen plain. From orbit it looks cold and silent and dead. It is none of those things. The same tidal forces that drive Io's volcanism, weaker at Europa's greater distance from Jupiter, but still significant, heat Europa's interior. Not enough to produce surface volcanism, but enough to do something remarkable. They keep water liquid. Below Europa's ice shell, estimated at between 10 and 30 kilometers thick, there is an ocean. A liquid water ocean. Global. Continuous. Extending across the entire subsurface of the moon in a layer estimated to be between 60 and 150 kilometers deep. Europa's ocean contains more liquid water than all of Earth's oceans combined. And it exists because Jupiter's gravity is squeezing Europa. Jupiter, the most dangerous place in the solar system, the radiation machine, the pressure crusher, the storm that has raged for centuries, is also the engine that keeps an ocean of liquid water in existence on a moon that would otherwise be frozen solid. The same gravitational force that killed the Galileo spacecraft. The same force that broke Comet Shoemaker-Levy 9 into 21 fragments and delivered them to Jupiter's atmosphere with the energy of thousands of nuclear weapons. That force, Jupiter's tidal gravity, is keeping an ocean warm and liquid right now. 628 million kilometers from Earth. Beneath 10 to 30 kilometers of ice. In the dark. And in that ocean, if the geological conditions are what the data suggests they are, there may be hydrothermal vents on the seafloor. Hot, chemically rich systems where Jupiter's tidal heat drives water through the rocky seafloor and back into the ocean, carrying minerals and energy. On Earth, hydrothermal vents support entire ecosystems that have never seen sunlight. Life built entirely on chemical energy rather than solar energy. Life in conditions that were once thought to be completely sterile. Europa has had those same conditions, potentially for billions of years, in a completely sealed ocean, with no outside contamination, with liquid water and chemical energy and mineral nutrients, everything that life as we know it requires, maintained by the tidal squeeze of the most violent planet in the solar system. Jupiter is simultaneously the most dangerous place in the solar system and the engine of the most promising habitat for life in the solar system. Creator and destroyer, at the same time, through the same mechanism. The universe does not separate these things. Jupiter does not choose between its roles. It simply exerts its gravitational influence and the results, violent death on Io, potential life in Europa's ocean, annihilating radiation throughout its magnetosphere, for 0.6 billion years of gravitational organization of the solar system that made Earth habitable, are all consequences of the same physics operating on the same mass in the same position. That is what Jupiter is. Jupiter will not always be as it is now. Over the remaining lifetime of the solar system, roughly 5 billion years until the Sun begins its transition to a red giant, Jupiter will change. Not dramatically in its own structure. Jupiter's core physics will remain stable for far longer than that. But the solar system around it will transform, and Jupiter's relationship to everything else will shift in ways that have profound consequences for the worlds in its system. As the Sun ages, it will gradually brighten, and in approximately 1 to 2 billion years, the increased solar output will push the habitable zone, the region where liquid water can exist on a planetary surface, outward from Earth's current orbit. Earth itself will eventually become too hot to support surface life as we know it, on a timescale of roughly 1 billion years before the Sun's red giant phase. But that same outward migration of the habitable zone moves it toward Jupiter's moons. The ice on the surfaces of Ganymede and Callisto, currently frozen in the deep cold of the outer solar system, will begin to melt. The surfaces of these already ocean-bearing moons will transform from frozen wastelands to open water worlds. Exposed surfaces, direct sunlight. For the first time in the history of the solar system, Jupiter's moons will sit in the solar habitable zone. For hundreds of millions of years, the Galilean moons may exist as ocean worlds, liquid water on their surfaces, sunlight available for photosynthesis for any life that has developed in the subsurface oceans and can find its way upward. If life exists in Europa's ocean today, and the conditions suggest it might, this is its potential window. The period when the solar habitable zone reaches Jupiter's orbit and the conditions on the surfaces of these moons become, for the first time, compatible with surface life. And then the sun continues expanding. The red giant phase arrives. The habitable zone moves further outward, and then the sun's outer atmosphere expands beyond Earth's orbit. Mercury and Venus are consumed. Earth's surface is sterilized. The inner solar system is engulfed by an expanded sun that would appear, from Jupiter's current orbit, as a sphere of red light spanning dozens of degrees of sky. Jupiter itself survives the red giant phase. Its orbit changes as the sun loses mass during the expansion. The gravitational dynamics of the solar system reorganize around the mass that remains. The moons continue orbiting. The radiation belts collapse as the solar wind that feeds them changes. Jupiter cools slowly as the internal heat that has driven its atmospheric dynamics for billions of years gradually bleeds away into space. The white dwarf that was once our sun, a cooling remnant the size of Earth, dense and hot, but generating only a fraction of its former energy, illuminates a transformed solar system. Jupiter orbits this remnant in the dark. Its atmosphere slowly cools. Its cloud bands quiet. The great red spot, if it has survived to this epoch, which it almost certainly has not, finally stops. Over trillions of years, the white dwarf cools toward a black dwarf, an object so cold it emits no detectable light. The solar system around it grows cold and dark and still. Jupiter's moons freeze completely. Whatever life may have flourished in Europa's ocean, if it existed, if it developed, if it had its moment in the sun during the habitable period, is long gone. Jupiter orbits the cooling remnant of the star that created it. Dark, cold, still massive, still the largest planet. Still, even in the deep future of a transformed solar system, the gravitational anchor it has always been. The last large moving thing in a system that has become a graveyard. Pioneer 10 left Earth in March 1972 and reached Jupiter in December 1973. It was the first human-made object to reach the outer solar system. The images it returned showed a planet of incomprehensible scale and complexity that stunned every scientist who saw them. Pioneer 11 followed. Then Voyager 1 and Voyager 2, whose Jupiter flyby images in 1979 remain among the most scientifically significant photographs ever taken. Then Galileo, then Cassini during its flyby, then New Horizons, and now Juno, still orbiting Jupiter right now in 2026, sending back data about Jupiter's atmosphere and magnetic field and interior that continues to revise our understanding of the largest planet in the solar system. 50 years of human spacecraft visiting Jupiter. 50 years of images and data and measurements that have made Jupiter progressively more extreme, more complex, and more important to the solar system story with every mission. And we have still only scratched the surface. We have never sent a probe deeper than 150 kilometers into Jupiter's atmosphere. The metallic hydrogen ocean that generates the magnetic field we have been measuring for decades, we have never directly observed it. The core at the center of Jupiter, the rocky remnant around which the entire planet assembled, we have never reached it. We are studying the surface of the most massive planet in the solar system from the outside, and what we have found on the outside alone has already rewritten our understanding of planetary science, atmospheric physics, magnetospheric dynamics, tidal geology, and the possibility of life beyond Earth. What the inside holds, what the metallic hydrogen ocean actually looks like at depth, what processes drive Jupiter's internal heat, what the transition between the gas atmosphere and the liquid interior actually involves at the molecular level, these remain genuinely unknown. Jupiter is 600 million kilometers away. The Juno spacecraft, traveling on an optimized trajectory, took 5 years to reach it. A crewed mission to Jupiter, if it were ever attempted, which current technology cannot support, would require propulsion and life support systems that do not yet exist and would expose the crew to radiation levels that no current shielding can adequately address. We are studying Jupiter from spacecraft that take years to reach it and can only survive its environment for a limited time before being destroyed by it. And yet, in 50 years of that limited, distant, constrained observation, What we have learned about this planet has transformed our understanding of the solar system more than almost any other scientific program in history. Now go back to that point of light in the night sky. The same point you looked at before this video started. The same pale gold steady light that you have probably seen dozens of times without thinking about it. You know what it is now. You know the scale of the storm inside it. You know what the radiation environment surrounding it would do to your body. You know about the ocean beneath the ice of its nearest large moon and the possibility that ocean is not empty. You know about the 21 fragments of a comet that hit it in 1994 and the fact that any one of those fragments hitting Earth instead would have ended complex surface life. You know that Jupiter's gravity reaches across hundreds of millions of kilometers to organize the asteroid belt, heat Io's interior, and squeeze Europa's ocean into warmth. You know that Jupiter is the reason the solar system has the architecture it has. That the position of every planet, the distribution of every asteroid, the trajectory of every comet that has ever crossed the inner solar system reflects Jupiter's gravitational influence operating over billions of years. You know that Jupiter does not know you exist. It does not aim its radiation at you. It does not choose which objects to deflect toward Earth and which to capture. It does not decide to heat Io into volcanic fury or maintain Europa's ocean. It simply has the mass it has in the orbit it has, and the consequences of that, the radiation belts and the storms and the crushed probes and the potential life in the subsurface ocean and the shaped solar system, are all automatic outputs of physics that does not require awareness to operate. The universe built something in our solar system that is simultaneously the most dangerous environment we have identified in our cosmic neighborhood, the engine of potential life on its moons, the gravitational guardian that has shaped Earth's impact history, and the object that will outlast almost every other thing in the solar system. And it sits there every clear night, visible to the naked eye, a steady gold point of light that most people walk past without a second thought. The king of the solar system has been above you your entire life. You just never looked long enough to understand what you were looking at. Look again tonight, and this time understand what is looking back. Jupiter is not finished with this solar system, and neither are we. Subscribe, because the next video goes somewhere even Jupiter cannot reach.